So if we're eating a shitty diet and we're living a shitty lifestyle and we're not doing things to take care of ourselves, like prioritizing sleep, prioritizing nutrition and phytonutrients, exercising, and, all the fundamental things that you would assume to kind of influence your health trajectory, well, guess what? You're going to age quicker.
Welcome to the Learn Skin podcast with me, Dr. Raja.
And me, Dr. Hadar, where we discuss all things skin.
Join us as we delve into the art and science of skin health in today's episode.
Hey, Raja, can you say the thing I told you to tell them?
Of course. We are board-certified dermatologists. This podcast is meant for educational and informational purposes only and is not considered medical advice, nor does it serve as a substitute for professional care by a doctor or other qualified medical professional. All opinions shared do not express the views of Learn Health, Inc. Let's get to the good stuff.
Hey, Raja, how are you today?
Hey, Hadar, how's it going? I've just been thinking, time's a-ticking, and we're getting older. What say you that we should talk about today?
Well, we all age. I remember when we first met, you remember me, I had a full set of hair, I had no wrinkles, and now time is flying, and we are all aging, and that's one of the inevitable processes in nature. But then more recently, some scientists have actually challenged this, and there's a whole growing field of aging that says, hey, wait a minute. Do we really have to age? Do we really have to kind of slowly march towards the end of our days? Or is there a way to stay young, not just by appearance, but intrinsically, from the very level of our cells? And that grew a whole field of aging. So it's not just what we look on the outside, but also what happens on the inside. And so it's a very, very rich, complex, popular topic, I should add. And so it's always good to have someone shepherd us through this process. What do you say we're being an expert in, huh?
I agree. And our topic today is clearance of senescent cells and skin rejuvenation. So I can't think of a better person to talk to than Dr. Anil Bajnath. And he is a board-certified family physician. He's written a couple books, but let me just give a little intro to him because we are talking about aging here. He is on the faculty in the Department of Clinical Research and Leadership at George Washington University School of Medicine. And he is teaching courses right now on the omics of medicine. Think proteomics, metabolomics, genomics. I mean, omics is the way of the world at this point. And he's also written a book called The Longevity Equation, the step-by-step blueprint to hack your genes, optimize your health, and master the art of existence. Well, if you know about the art of existence, I'm glad you exist here with us today, Anil. Thank you for joining us.
Thank you guys so much for having me. It's a true pleasure. I appreciate that.
One thing I wanted to ask you, Anil, just briefly, if you can tell us, how did you get interested in this whole area of aging? You did run-of-the-mill courses in medical school, then decided to focus on family practice, but then something came up and told you, hey, I should look into that. Was that the story or what happened?
No, actually, the story begins many moons prior to medical school. My interest in integrative medicine began as a teenager, working at Whole Foods Market back when it was owned by a bunch of hippies. And before Amazon got on it, and I was working in that robust vitamin department that we all walk through and look at the probiotics in the refrigerated section and the protein powders and all the wonderful salts and wonderful bath products that they have that smell so wonderful. That back then it was known as a whole body department, and got my first taste of integrative medicine at a younger age, for which, when I was there, Whole Foods would send us out to all these conferences around the country, facilitated by researchers and physicians from around the world. So at a very young age, I was exposed to these different concepts of integrative medicine, natural medicine. And, from there, I was introduced into a very unique technique using dark field phase contrast microscopy by one of my wrestling coaches. And this technique opened up a whole nother world of research and development for me. And I thought for the longest while I wanted to be a humanopathologist until I worked with them at MD Anderson Cancer Research Center in Orlando, Florida, and realized that I wanted to do more in my clinical practice. So I majored in molecular microbiology and medical laboratory science to kind of formalize that integrative technique of dark field phase contrast microscopy, analyzing undenatured peripheral blood, looking at various morphologies of how the blood changes shape, structure, function, and dynamics based on our exposome, or essentially what's coming into our bubble. And from there, studied with some European clinics out of Germany and Switzerland, and was really obsessed with, this European biological medicine approach to longevity and holistic medicine. But ultimately, bit the bullet, became a allopathic MD trained physician, despite my deep-seated philosophical orientation towards, more Eastern philosophies. Yeah, then went to med school, and even prior to med school, was studying anti-aging, regenerative medicine, and functional medicine, and which has led me down this road of all these fun little things that I'm into now, and writing the book and putting all this stuff together here.
What a great story. Yeah.
Yeah, very non-traditional.
Yeah, absolutely. And you heard it here first, kids. If you take whole foods and add wrestling, you will become a doctor. What a wonderful path.
Yeah, we're evidence-based here. Absolutely. One thing I was going to say is, in some ways, to change medicine, you got to know medicine, right?
Of course.
Like, I think if you're not trained in medicine, I'm not saying you have to be a physician, but if you're not trained in medicine or in evidence, it becomes hard to change the field, don't you think, Anil? And I feel like you have such a great position to have been trained within it, see where it works, see where maybe we fell short, and then kind of extend all of these new technologies into how we understand the human body.
I agree. I think, my foundations in molecular microbiology and medical laboratory science has really prepared me to be a, very astute analytical physician, questioning the evidence, but it also opened up the paradigm, shift in my approach to personalized medicine, that are we really practicing evidence-based medicine in modern practice and with our current guidelines and infrastructure? And I would question that framework because, as we move forward, especially with the completion of the Human Genome Project, we know that everybody's genomic and DNA blueprint is unique and possesses instructions inherited, primarily 50% from your biological mother and 50% from your biological father, that gives us that framework of kind of a roadmap on how our body works and operates. And that framework is not going to respond the same nutrigenetically or nutrigenomically and pharmacogenetically. So when it comes down to it, our clinical response to intervention is highly individualized, and it's very important to look at the context of the individual and taking into consideration clinical decision makers, and I could unpack all sorts of things from the lipidology world or, the evidence-based neurology practices and so forth. But I really think that the future, in my opinion, is going to be the omics of medicine, connecting those molecular dots from genome to pathophenome and looking at things through the N of one lens, where, everybody's at the center of their own kind of personal research study. Their book of life is being translated. And I'm also looking at individuals through the context of how do we reverse your biological age? How do we work backward to undo some of the damage that might have been accumulated due to a lifetime of exposure and other antecedents, triggers, or mediators that influence your current health expression?
This is a great segue because, I was just looking at this. Did you guys hear? I guess this is really, I'm not remembering who it was, like a really rich, is it a billionaire or some guy who's trying to spend like millions of dollars trying to reverse his age and whatnot. And I think this whole concept of reversing your age or like going and making yourself a more youthful version is obviously on a lot of people's minds, which leads to one of the questions that I wanted to ask you. What causes our cells to senesce, or the formation of senescent cells? Can you take us through the science of this? What is it that is the underpinnings of aging?
That's a great question. And I think it's multifactorial. And I think additionally, you were referring to that tech billionaire. I think his name is Brian Johnson, if I'm not
mistaken. The billionaire. That's right.
Yeah, and he had like 30 different doctors and has spent $2 million on reversing his biological age. Now, if we don't have access to those resources, which I don't think the 99 percentile have access to, what do we do? How do we unpack these kind of different factors that influence and mediate the biological aging process? Well, that actually brings us into a very amazing study and publication that was just recently updated last month, which is centered around the hallmarks of aging. Now, the hallmarks of aging, originally 10 years ago in 2013, was published, and there was 9 original hallmarks. but it was recently updated last month to incorporate 3 additional hallmarks, which I think was much needed, and put into further context a role of, dysregulated macroautophagy, chronic inflammation, and dysbiosis or imbalance of the gut microbiome. But what kind of preceded that with the original hallmarks was looking at, these different factors like genomic instability, telomere attrition, loss of proteostasis, and epigenetic alteration, which led into dysregulated nutrient signaling, and additionally looking at cellular senescence formation, which then altered, stem cell rejuvenation and altered cellular communication, which was kind of the fundamental hallmarks that were designated clinically to regulate the biological aging process. And what sits uniquely within this framework is the role of senescent cells. Now, senescent cells are very interesting because senescent cells was originally kind of discovered incidentally in 1951 in the lab of Dr. Hayflick and Moorhead, where they were studying human fibroblast cells and then studying their mitotic index potential. And what they found was after 50 or so cellular divisions, that these cells lost the ability to divide, but they did not undergo apoptosis or programmed cell death. So they weren't necessarily dead. They weren't alive, and they were characterized to be locked into the suspended state of animation, where they were still metabolically active. And we know now today that they were locked into G1 interphase, or the gap phase of the cell cycle arrest. So they were arrested in this metabolically active state of the cell cycle, and they were producing all these very unique features, which is known now as the SASP, or the senescence-associated secretory phenotype, which is essentially all these different pro-inflammatory markers. But what led to these cells' development? Well, over time, as we know, there are different mechanisms of cellular injury. And most, kind of identified forms of injury include mitochondrial damage, increasing reactive oxygen species, membrane damage, and protein misfolding. And what happens when cells are faced with irreversible damage? Well, they have two fates. A couple of different fates. And most notably, apoptosis or programmed cell death, the removal through autophagy or cellular recycling, or necrosis, which is, passive accidental cell death, which results in a very strong inflammatory signaling. So ultimately, these cells that don't necessarily go through those removal capacities are locked into, persistent existence. And that leads to this whole development of senescent cells or zombie cells. And what's interesting about these zombie cells, research has shown that just one senescent cell out of 7,000 to 15,000 cells can initiate degenerative aging. So it's a very important factor in accelerating the aging process. And there are different types of senescent cells and the way they develop. Some are replicative senescence due to those mitotic divisions, and some are stress-induced due to, various other factors such as DNA damage, the activation of oncogenic activity due to a gain of function, and disrupted autophagy, which is the body's cellular recycling mechanisms, mitochondrial dysfunction. NAD, nicotinamide adenine dinucleotide, is another very important factor that regulates senescent cells. Blood sugar dysregulation, hypoxia or low oxygen, and even the accumulation of excess metals such as zinc, iron, and copper can accelerate the senescent cell formation. And with time and activation, these cells become, transition into the state of suspended animation. It's also known as zombie cells in the literature. And they possess very unique features. And, they are able to evade apoptosis through advanced P53, P21, and P16 expression. They're metabolically active, producing those senescent-associated secretory proteins and phenotypes. They lead to, all these other kind of surrogate biomarker accumulations in the system. For example, one of the best biomarkers we have to gauge senescent cell activity in our system is something called SA, which stands for senescent-associated beta-galactosidase. The SA beta galactosidase is one of the, key hallmark biomarkers that is used clinically to gauge the accumulation and the burden of these senescent cells. And as these cells accumulate in the system, it just only serves to accelerate the biological aging process. And what's interesting is that, there is a unique balance with these cells where we actually need it earlier on in life. It's very important in embryogenesis and development and wound healing. But what ends up happening is when these cells outpace the ability of the immune system to remove them from circulation, they start accumulating. And this is a tipping point where it's now led into a state of not transient senescence, but persistent senescence. And this leads to tumor progression, chronic inflammation, and age-related diseases. And it's actually a very interesting area for clinical research and development right now, most notably out of Mayo Clinic and Dr. Kirkland's lab, where they're investigating all sorts of different agents to help remove these different forms of senescent cells from our circulation. So that's kind of the high-level overview of, how they're formed and how they work. But yeah, it's a very important area of clinical research and development as we speak.
Anil, thank you so much. That was probably one of the best overviews that I've heard in a while that really was comprehensive and succinct, and you did it in a few minutes. So clearly you've done this before. I know you're a teacher, and it's pretty notable. And, for those of you who are listening to these concepts for the first time, there's no shame. Just rewind this podcast and listen again, because everything here was spot on, and I appreciate that. You alluded to the fact that now we are, with advanced technology, can actually try to diagnose this, because it's clear, I think, to everybody that these processes that happen invisibly inside our cells are very visible to us. We are a fairly aging society, but not just we get old, we also don't live well. Quality of our life is not as great. So even though compared to maybe 50 years ago, we tend to live longer, the quality of these added years is not necessarily great, with dementia and metabolic syndrome and cancer. And all of these have been linked to these processes that Anil has described so eloquently. I'm wondering now for, the folks that are listening and saying, okay, what can I do with this in clinic? Can we now diagnose this in a clinically relevant manner?
That's a great question. So commercially facing labs right now, there's only about 2 or 3 that have any form of testing that could be reflective of senescent cell burden. Now, there is some evidence. There are 3 studies that I've come across that looked at ferritin being a kind of a surrogate marker for cellular senescence, but I don't think that's going to cut it. We could use the ferritin clinically to kind of gauge, how we modulate some of those acute phase reactants, which could be a part of the SAS proteins, or the senescent-associated secretory phenotype, as we kind of clear out some of these senescent cells. One of the labs that I have no commercial interest with, but I do respect, is Ginfinity Labs with Dr. Shi. Now, he's received several $1 million in NIH funding in the field of research, and he's done research on cervical cancer and senescent cells. And he has a commercial-facing lab that has a couple of different biomarkers for aging. And it's the only lab that I've seen so far that has the SA beta galactosidase. He also has an intracellular NAD test and a couple of other tests to assess biological aging as a whole. So clinically, I do think that, there are some tests out there. Depends on how you want to do it, if and what type of model you work in. But another test that I really like is the True Diagnostic True Age, and TRU Age test out of Louisville, Kentucky. And I like that test because it's actually looking at a lot of different what's called epigenetic methylation patterns based on these different clock genes that are pretty well established in the literature of aging, like the Horvath clock and the Levine clock. And they've aggregated this information into an algorithm that is used to give you what's called a biological age report. Now we're looking at the pace of aging, the intrinsic and extrinsic forms of aging. And it's also looking at your telomerase activity and stem cell replication. So to me, that's one of the best benchmarks clinically from a longevity medical practice standpoint that could be used to establish a baseline of where this individual is clinically with their aging trajectory.
And do you know briefly, do you happen to know what tissue they use? Is this just a blood sample?
So they're using blood, and it's a very great test. I like the test because it told me that I was younger than my chronological age by a couple of years. So
Maybe it's an opportunity for you to explain it to our audience. What is a biological age compared to the chronologic age?
oh, that's a great question. And I do apologize. I'm throwing these terms around as though, this is common knowledge. So I do apologize. But essentially, as you may, infer from chronological age, refers to essentially your calendar age, when you were born and how many days you've made it around the universe here. So that's
Right.
just your calendar age. And your biological age is a little bit different. It's actually looking at these various patterns of epigenetic methylation. Now, what is epigenetics? Actually, that's part of my course that I teach on the Omics of Medicine, where we look at essentially the environmental interface on DNA expression. As we know, what drives aging is a bioaccumulation of damage, right? And this damage could manifest in different ways clinically, and it also is triggered by various different, what I call signals and inputs. And these signals and inputs influence essentially how your DNA is going to be expressed. So if we're eating a shitty diet, right, and we're living a shitty lifestyle, and we're not doing things to take care of ourselves, like prioritizing sleep, prioritizing nutrition and phytonutrients, exercising, right, and all the fundamental things that you would assume to kind of influence your health trajectory, well, guess what? You're going to age quicker, and we can measure that. And I think that whole concept of measuring those methylation patterns on your various loci of your genes gives us kind of like a roadmap of what we need to prioritize clinically to address these fundamental drivers of aging, right? And
Right.
also, this is from an aging perspective. I want to keep in mind that the hallmarks of aging and the hallmarks of cancer are very similar, right? And what we're finding too, there are these other commercial tests that I use clinically to identify, hey, do we have any cancer cells floating around in system that's not being detected by conventional diagnostic techniques, right? Because according to the USPSTF, we're lucky to screen for 4 to 5 different cancers in our lifetime. What about all the other things? Well, research is showing that the same concept of DNA methylation or cell-free DNA methylation patterns in circulation can be used for early detection and screening for cancer. All right, cool. So what we're noticing in with the, evolution here of diagnostics from a medical laboratory science background and, the evolution of medicines, we have these different tools and resources that we could use clinically to kind of detect early augmentations in aging or cancer. And we should use it too, with all intents and purposes, to enhance our longevity. And that's what I try to do and capture clinically.
Yeah, no, absolutely. That was great. And, one of the nice analogies I like for epigenetics and aging comes from David Sinclair, and he talks about a CD disc. So for those of you who were born, 20 years ago or more, you probably remember those CDs. And we always thought that maybe, the disc is broken and you can't read the code on it anymore. But really what it is, it's just not accessible or maybe scratched a little bit. And if we can just remove that, that code is still there. The genome is still there. It can still be read, can still be effectively translated into proteins. And all we need to do is just improve that with a good therapy. And speaking of that, I really wanted to get to the point of senolytics and treatment of this, because you took us through some of the fundamentals of aging and senescence, and perhaps we are coming to the age of diagnostics, and maybe we can even tell what that means when we see it. But already before all of that, the treatment arena is also growing, and maybe you can in a few minutes just give us a little bit of the introduction to senolytic agents, and maybe we can use skin as an organ of example for how this can be used in rejuvenating the skin.
Well, I think that's absolutely. That's a very important concept here. And I think, skin aging, like aging of any other organ, is characterized, again, by that progressive loss of functionality and regenerative potential. It's a multifactorial process that, affects nearly every aspect of the biology and function. And the skin is merely just another manifestation of how, our tissues are susceptible to these different insults and injury. And, again, from a fundamental standpoint, anatomical, conventional standpoint, the skin represents, a dynamic and complex organ with its unique structure and function. It consists of different cellular types and compartments, with each compartment leading to different unique constitutional makeup and function. And we know that the outermost layer of the skin is the epidermis, and it consists of 4 subtypes, namely the stratum, corneum, granulosum, spinosum, and basalis. And there's 4 major cell types, the keratinocytes, melanocytes, Langerhans, and Merkel cells. And the border between the epidermis and the dermis is the epidermal junction, which represents an aggregation of protein structures known as a basement membrane. And below that basement membrane, there is an underlying dermis, which provides that structural support as well as nutrition and circulation. Now, what's important is the dermis not only comprises, dendritic cells, macrophages, and mast cells, but those same cells called fibroblasts, which produce very important interconnected extracellular matrix, right? And collagen and elastic fibers, right? And that is where, I think it leads us back to the original work of Hayflick and aminofibroblasts that he was studying in a petri dish over, oh my goodness, 70 years ago. That's, 70 years ago with incidental finding. So as, these senescent cells accumulate, and in its original format that was originally studied by Hayflick, once we lose the integrity of those fibroblast cells, our regenerative potential is going to be lacking. And we already know that skin, being one of the largest organs in our system, is the most susceptible to environmental insults due to numerous factors, most notably UVB irradiation, right? And that irradiation leads to those thymine dimers and DNA damage. That DNA damage, which accumulates over time, obviously could lead to cancer, but it also could lead to the accumulation and formation of these senescent cells. And as these senescent cells accumulate, right, and essentially start spewing out those SAS proteins, right, it's going to accelerate the aging process. So with that being said, there's so many different factors that influence that decline in skin integrity, right? And including different biomarkers like, CD44 glycoprotein, which is a known marker for skin aging. It's a key regulator of keratinocytes proliferation and the maintenance of hyaluronic acid homeostasis. And it's been shown to decline with the accumulation of senescent cells, right? So once we lose, some of that regenerative potential, it's just, an accelerated process here of, I think, skin degradation. And let's not neglect, the important role of the dermal extracellular matrix and its role in structural function and integrity and how it's involved intrinsically and extrinsically with aged skin. So there's a lot of different factors here how the senescent cells could influence skin and aging. Now, there's a lot more studies being done neurologically, cardiovascularly, pulmonary system, and so forth, clinically right now around senescent cells. That's just where the money is being funneled into Alzheimer's, Parkinson's research, cardiac fibrosis, pulmonary fibrosis, diabetic kidney issues. So that's where the bulk of the human clinical studies have gone. Now, there are numerous different agents that have been shown to work to help remove these senescent cells from circulation. And this gives rise to a category of medications that are on the horizon here that are, I think, going to be very commercially available very soon. And these agents are either known as senolytics or synomorphic agents. So senolytic agents are essentially agents that are going to go in there and kill and lyse those senescent cells. Synomorphic agents are agents that are going to go in there and kind of attenuate that inflammatory SAS protein signaling. Now, it's very interesting because I think the combination of the two is going to be quite powerful. And how is this applied to, skin health as a whole? I think our greatest opportunity is going to be in the synomorphic arena. And the reason being is because there's strong research and evidence in human studies that there are these various polyphenols and plant compounds that have been shown to help with skin structure, function, and integrity, and decrease the accumulation of senescent cell burden. And those same polyphenols and natural occurring agents are kind of some of the agents that are found in some of these topical solutions, anti-aging cosmetic products that are available commercially, right? Most notably, some of the most, I would say, well-researched compounds include quercetin, right? Which is a flavonoid that's been shown to, do all sorts of things. I can't even begin to tell you. It's found in citrus, right? And we know that there's a lot of different citrus extracts that are found in some of these topical solutions. Also, there's another very important senolytic compound called fisetin. And fisetin is essentially a compound derived from, various fruits, most notably strawberries. And it's been shown to actually be a very potent senolytic agent. And there are some pretty decent aging studies around senescence and skin cells in mouse trials that have shown tremendous promise that these different phytonutrients have a lot of benefit at the potential of removing some of these accumulated senescent cells from our circulation. So I definitely think quercetin, fisetin, and, there's a handful of these other plant compounds and polyphenols that are out there, like resveratrol. You referenced David Sinclair and his analogy of epigenetics as it relates to the CD scratches, so to speak. He's a really big resveratrol advocate. So I think that all these different phytonutrients have the potential at supporting and, the aging process and removing the senescent cells. And there's a lot of studies on the horizon here. I'm more excited, clinically on how we could reverse the entire biological age kind of profile. And, and clinically, I'm using a couple of different agents, including, some of these plant-based compound formulas, but also exploring the role of like rapamycin, which is an agent that's used traditionally in host first graft rejection in transplant patients. So it's most notably used to suppress the immune system. But what we're finding is that in low doses, it actually works on a very important molecular target called mTOR, right? mTOR is a mammalian target of rapamycin and is essentially almost a molecular master switch, which turns on this biological process of cellular recycling known as autophagy. And autophagy is essentially your body's ability to go in there and clear out all the bad stuff, right, through immune-mediated recycling processes. And essentially, this mTOR, this mammalian target of rapamycin, is one of the key targets for going in there and inducing autophagy and removing these different damaged organelles and different types of cells and so forth from circulation. And that's one of our greatest opportunities clinically is to induce autophagy. Now, autophagy is also induced by fasting, right? So we know that there's great evidence around, intermittent fasting. 18.6, there's a great New England Journal of Medicine publication, I think from 2018, if I'm not mistaken, that looked at 18.6 intermittent fasting in conjunction with keto diet having longevity promoting benefits. Oh my gosh, New England Journal of Medicine is talking about longevity. That's crazy.
I know they have something on the fasting mimicking diet. And that's a little bit more of a product-based thing, but there's some studies that have looked at it even from a skin perspective. I think that fasting is now, becoming more and more clear that there's benefits there as well.
Yeah, absolutely. Fasting and exercise, it's kind of funny that we're getting back to the basics when we try to look at this. The plants that have been on the planet for eons have developed all these molecules to help them and kind of selected for aging on one hand. And then what we know all the time, what promotes health overall, which is keeping our body active, but also challenging our body, really awakening those pathways, like even exposure to extreme cold or heat can sometimes do this. And obviously, as you mentioned, fasting. I mean, obviously, this is way beyond, and I appreciate Anil bringing that up because it is important to remember that even though we started talking about skin, at the end of the day, the skin is a manifestation of what's happening on the inside. And certainly trying to fight aging for improving your health is probably more than a process of just, smearing something on and trying to make your skin look better. It is a wholesome process from the inside out, which is what we've been talking about throughout this program all these years. So spot on. Thank you again for bringing this to the fore here.
Anil, this has been awesome. We've covered a lot of ground, but I also want all the listeners to hear about what you're doing and how you're practicing. So can you tell us about your private practice and what you're doing there?
Oh, thank you. Yeah, so essentially, my private practice with the Institute for Human Optimization is essentially a clinical manifestation of the courses that I teach at the university, where I'm trying to connect the molecular dots from genome to pathophenome, looking at your DNA, your epigenome, your proteome, your metabolome, your envirobiome, and in certain instances, even your transcriptome. All fancy words, but essentially my entire goal and intention is to reverse your biological age. And you can find me at ifho.org, which is the Institute for Human Optimization. And you could schedule a discovery call to kind of unpack and discuss, your health goals even further. I am licensed throughout the country and seeing people all over the world.
I want to thank you for joining us for this. This was obviously a tour de force. And like I mentioned, folks, rewind this, listen again. So much great information summarized here. And clearly, I know we need to bring you back here for another episode to try to maybe uncover some more wholesome pathways, maybe talk about fibrosis and those agents, because it's really a huge, huge clinical problem that current healthcare interventions cannot address, and maybe beyond that. So thank you for your time, your expertise. I'm looking forward to more conversations.
Thank you, guys. I appreciate it.
Guess what, Hadar?
What?
Tickets are selling so fast for the 6th Annual Integrative Dermatology Symposium.
Really? Wow, that's amazing. I mean, each time this event gets better and better.
Yes, it does. And as a special gift to our podcast listeners, all of you, we're offering 15% off registration using the code PODCAST15.
PODCAST15 for 15% off. That's a great deal. And prices won't be going any lower this year, so hurry up and get that discount.
So true. And if you haven't joined us in person yet, we can't wait to see you. And this is the year to come have fun at the Grand Casino Resort in Reno, Nevada.
Yes, we are excited to see you, and together with Raja and myself and other practitioners, you will get to connect with everybody, engage with the exciting research and content, and learn what the integrative movement is all about as we get inspired by the Sierra Nevada mountain range and, my friend, downtown Reno.
All that nestling sounds fantastic. Dad joke alert, maybe even skin-tastic. I know we're all about having fun at the symposium, but this year's over the top. Now, I'm not much of a golfer, but for you golfers out there, they have over 40 courses, but they also have rock climbing, equestrian trails, boat tours, pools, arcades, and so much more to just relax.
Oh my gosh, this definitely sounds like a family-friendly getaway. I know I'm bringing the kids. And while they're at the movies, Raja, you and I, my friend, no pun intended here, but we'll be feasting on a lot of nutrition.
That's right. This year's theme has been long awaited. Nourish the gut, nourish the skin, and we'll be delving into nutrition.
Oh my gosh, we can't wait to see you. Come be with us at the IDS on October 27th to the 29th, in person or virtually. See you in Reno.